Hey there, Overlanders. If you're anything like my wife and I, you've probably been frustrated on many of your trips in getting online. There are many areas around the country, especially in remote areas, where there just isn't cell coverage or very poor cell coverage. So, whether that's to download the directions to your next destination or uploading videos or staying in touch with friends in social media, whatever it might be, um, it can be pretty frustrating at times. So we decided to upgrade our mobile cellular hotspot capability. I realize this solution isn't necessarily applicable for everyone because of space requirements and the like, but I think you'll find some interesting information in here and perhaps inspire you to do something about your mobile cellular hotspot capability beyond hotspotting to your phone, which is what we've been doing for many years. So here goes, and hope you enjoy the content. So there are four parts to this video. The first part is a system overview, which is a short video overview of what the system looked like. It's just to whet your appetite. Then there is a detailed list of system components. Then we go in through a performance test to see the difference between the two types of antennas. And then finally, what your neighbor sees and what it looks like in sort of a time-lapse format setting up the system. So here we go. All right, so part one, system overview. So this is what it looks like from the back of the vehicle. It's laying down on the roof right now, and so you can see the dual Yagi antennas there. You can see the ultra low loss coax cable that I've routed down through the support pole. I've got a couple of quick fist clamps here mounted to the roof to hold down the top of the pole, make sure it doesn't go anywhere. Love these things. If you haven't used them before, give them a try. They're fantastic. So we'll head on into the vehicle here and open up the hatch and get up on the roof and show you what that looks like. So we're going to enable the roof hatch and open it up with the remote. We'll speed up the video here so you don't have to wait for the incredibly slow roof hatch to open. So we'll head up on the roof here so you can look at some of the system components that are mounted up here. So this is the rotary table and ratchet mount for the antenna pole. That's a 12-foot inch and 3/8 pole with the dual Yagis on the end there. This is the base plate that I made for the support poles, and we also mount a telescoping ladder up here as well that's not shown. So we'll unstrap the support poles. Right now we're just using this Velcro tie. Probably change that out for another quick fist product here in the future, but it does what we need for it at the moment. We'll undo this ratchet clamp here so we can lift the pole. We need to pull the support poles down a little bit to the stop clamp to help us pull the pole up. And we raise the pole. It's not too bad. It's a little unwieldy, but works out all right. First thing we do after we get the pole up is to relatch our ratchet clamp so that holds the pole mostly vertically. And then we'll attach our support poles, quick disconnects. We have them at 90 degrees apart. So since they're rigid poles, they support in both compression and tension loading. So at 90 degrees apart gives us all the support we need for the pole. So next we will lower our compression clamp, and that squeezes the two collars together and provides nice secure support while still allowing the pole to rotate. Speaking of rotation, we'll show you how the rotary table works. So you pull the pawl and you can rotate it to 16 different locations around the perimeter. First rotations were in the clockwise direction, and now we're going back in the counterclockwise direction. So it gives us 360-degree coverage, 180 degrees in clockwise and 180 degrees in counterclockwise. So we'll loosen the compression clamp up and raise that so that we can start the process of lowering the antenna. So we'll release the quick disconnects for the support poles. All right, we've got those loose. Now we'll undo the ratchet clamp so we can lower the pole. Collars are up against the stop collar at the bottom there so that we can pull on those while we're lowering the antenna. Pulling backwards on the support poles while holding up a little bit on the main pole allows you to lower it down pretty easily and rest it on the quick fist clamp. Once we have the pole down, we can re-clamp the ratchet clamp there and slide the support poles up. Since we move the compression collar up, that gives us room to slide the poles up before we secure them against the main pole with the Velcro strap, soon to be a quick fist strap. The support poles really can't go anywhere, but you want to make sure that everything is really secured well, especially if you're traveling over miles and miles of corrugated road. As you all know, it can shake everything apart, so you got to tie it down. So then we'll open up the quick fist clamps down there and push the pole back down into them and secure them, and that's pretty much it. What's needed to deploy and put away the dual Yagi antenna on the roof. Next, we'll talk about some of the components that go into building a system like this. So stay tuned for the parts list. You can see the omnidirectional cellular antennas at the top, the Wi-Fi antennas in the middle, and the GPS antenna coming out the bottom there. Two 30-foot rolls of 50 ohm ultra-low loss coax cable, a 2-position RF coax switch supporting 18 gigahertz. Here's the installed DIY router and antenna module. This is a stainless steel VHF antenna ratchet clamp. This is an adapter bushing to go from the ratchet clamp to the 1 3/8 pole. Ratchet clamp assembly with the bushing installed on the threads. This is the stainless steel rotary index table. The bottom of the rotary table looks like this with 16 index points. This just shows the two components stacked minus the adapter plate. Alright, so we got out the bandsaw and cut up this 1/4-inch aluminum plate. It looks like this. Tapped the holes for mounting the things we needed to mount on the plate. We mounted the rotary table and ratchet clamp on the plate, then drilled a bunch of holes to lose some weight on the plate. Glued a 1/16-inch EPDM rubber mat to the back of the plate. Routed the two 30-foot ultra-low loss coax cables through the antenna pole. I followed the instructions from my chief electrician to get the DC power routed from the electrical panel over where we needed it. We replaced the old 75 ohm coax with the new 50 ohm. And we bored a hole through the back of the bulkhead so that we could route the antenna cables into the spot where we're mounting the router and antenna module, right in front of the AC unit. And there's the router and antenna module in its new home. We level the vehicle and use a post leveler to get the pole straight so we could cut the support poles at the right length. Now we get to find out if all this was worth the effort. Turn on the Wi-Fi system and go over and verify the omnidirectional antenna is selected, and looks like it is. In case you didn't catch that message I flashed up, we have very poor cell coverage here at our home in the mountains, and without Wi-Fi calling, essentially you're limited to text. No voice, no real downloading or internet connectivity with a cell phone. Okay, so we got a couple of bars at minus 92 dB on the signal strength. Not great, but much better than our cell phones still. So we'll look to see what that does for us on the internet. We'll do a speed test here. We'll do 3 of them in a row, and I'll speed them up so you don't have to wait forever. We'll look at the 3 runs together on the summary page. when these 3 tests complete, and we'll see how we do with the internal omnidirectional antenna. So it looks like we have about 1.5 on the download and about 2 on the upload. We will switch over to the external dual Yagi antenna that we looked at earlier and see how it does with the speed test. Well, it looks like we got a couple more bars and minus 80 dB on the signal strength. Looks like we can actually lock on band 12 with this antenna, so we'll go ahead and do that and run the test. We weren't able to get a band lock on any of the available frequencies using the omnidirectional antenna, so we stayed with the 850 megahertz one, but it looks like with the directional dual Yagi antennas we're able to get a band lock on B12, so we'll lock on that and see what kind of performance we get with that frequency and the dual antennas. Well, that was pretty exciting. So it looks like we have a 5x increase on the download and an 8x increase for the upload. So that's awesome.